I hope you're able to see the screen.
Yes, sir.
So we'll get started. So last class we discussed about Earth's magnetism, right? So our main discussion was about Earth's magnetism. In that, I told you there are three important points to be kept in your mind. One is magnetic declination. The other name for magnetic declination is magnetic variation. So how do you define it? It is defined as the angle between the geographic meridian and the magnetic meridian. The second point is we saw the horizontal component of the Earth's magnetic field, which is given by BH cos delta, where delta stands for what? Angle of
dip.
Yes, it's called angle of dip or inclination also. But the most commonly used term is angle of dip. Then the vertical component of Earth's magnetic field is given as B sine delta. Then BV by BH is equal to tan delta, and B is equal to root of BH square plus BV square. 1 minute. Okay. So B is equal to root of BH square plus BV square. These points are not needed. So we don't study about neutral points. Then we know what is angle of dip also, right? The angle made by the Earth's magnetic field at a particular point with respect to the horizontal component of the Earth's magnetic field. So Earth's magnetic field with respect to its horizontal component is what is called as the angle of dip, and it is represented by the symbol delta. Right? Keeping all these points in mind, we will do some problems. The first one is the declination at a place is 15 degrees west of north. Okay. So I hope you guys are able to see the question. The declination at a place is 15 degrees west of north. In which direction should a ship be steered so it reaches a place due east? So where is the ship expected to reach actually? Read the question. You guys read it. So what is the expectation? In which direction should a ship be steered so that it reaches a place due east? So what is the expected location? It should reach the east, right? So east, west, north, south. Okay. So in physics, there are two terms used. Okay. One is they use it like northwest. Let me take as an example. Northwest is one of the points. West of north is another point. Okay. They can either say northwest or west of north. What is the difference between both? So when you see northwest, what do you mean?
Between north and
Then west of north?
any side between north and south.
No. See, in both the terms are same. Sorry, west of north is
the angle made from west to north.
West to north. Okay, I will draw it like this. Okay, west to north. There is some line like this. Okay, I'm taking it. Now, which angle should be taken as 15 degrees? This one or this one? So first option or second option, because they're saying 15 degrees west of north. So which one should I take as?
First
First
one.
answer.
First option.
Yes, you should take this as 15 degrees north. Okay, so I've drawn the diagram in the wrong way. So what is the meaning of it? Means from north, you're turning towards the west by an angle of 15 degrees. That is the meaning. Okay, then what does northwest mean? So wherever you see northwest, then what do you mean by that?
45 degree maybe.
That's right. So it is exactly the angular bisector. So it will exactly be 45 degrees with respect to north and east. That's right. So it is 15 degrees. This is the magnetic north. Okay, can I put it like this? and this is the geographic north. This is the geographic south, and this is the magnetic south. Accepted? So we know that there will always be an angle existing between the magnetic north and the geographic north. At this location, the angle that is existing between them is 15 degrees, and this 15 degrees is what is called as magnetic declination. Now you guys tell me, answer is very simple. In how much degrees more is the steering supposed to be rotated so that he is able to reach east?
105 degrees.
It is 105 because you have 90 degrees here. Means had it been exact north, right, had it gone exactly in the north direction, to turn towards east, it should make an angle of 90 degrees in the clockwise direction. But since there is a 15 degrees error, we can treat it like a zero error. Okay, since there is a 15-degree error, you should steer it in the angle 105 degrees with respect to whom? With the
East.
east or direction of compass of needle. To put it very simple, what you told is right. 105 degrees with the direction of east. That's it. I hope you guys are able to understand this. So this is how the problem will be asked. Okay, make a note of it. Shall I move on to the next one?
Yes, sir.
You guys try this. A ship, I'll give you 3 minutes time, try it. A ship is to reach a place 10 degrees south of west. In which direction should it be steered if the declination at that place is 18 degrees west of north? Don't look at the answer. You people try. Yes. So how can we solve this?
90 plus 10 minus 18.
90 plus
10 minus 18.
Oh, okay. Tell me how to do it. Tell me the steps, okay? So, yeah. So this is what direction? This one, the top one.
North.
North.
What north?
Geographic
north.
north.
There's geographic south, there's geographic west, and geographic east. Accepted? So where is the ship expected to reach? The ship is expected to reach 10 degrees west of south, means from west it is towards west. Yes, 10 degrees below west. But how much is the declination at that place? It is 18 degrees west of north. Means which one should we take? 18 degrees west of north means to be like this. Okay. So in this, if you rotate it in this way, so how much where should I take it? Close to north or close to west?
Close to
Close to north.
Yes, close to north, west of north. So this will be 18 degrees. Right. Now what are they asking? In which direction should it be steered so that he is able to reach the destination? So how to do this, guys?
Sir, how it is close to north, sir? I got confused.
Listen. West of north means from north he is turning towards west. That is the meaning. These kind of questions will be used in the relative velocity concept also. So make sure you're clear with this. West of north means from north to the direction of west, the angle is 18 degrees. That is why it is close to north. Okay.
Okay, sir. Thank you.
Yeah. So if I draw it like this will be magnetic north. This will be magnetic south. This will be magnetic east, and this will be magnetic west. Now tell me what should be the answer. So with respect to the original direction, how much is it? It is 90.
80 minus
90.
80 plus 10.
Yes, 90 plus 10 first. 90 plus 10 minus 18. That's right. So 90 plus 10, how much? 100 minus 18, be 82 degrees. I hope it is easy. So we'll do one last problem, then we can go to the next chapter. So in the magnetic meridian of a certain place, the horizontal component of the Earth's magnetic field is 0.26 cos, and the dip angle is 60 degrees. What is the magnetic field of the Earth in this location? Just give me a minute. Tell me how to do this. The magnetic meridian of a certain place, the horizontal component of Earth's magnetic field is 0.26. So what have they given?
We have to use the formula BH is equal to BV cos theta.
BE. No, it is BE. It is not BV. BV is vertical. Did you say BE or BV?
BE, sir.
E. So it's BE cos delta, and the dip angle is 60 degrees. What is the magnetic field of the Earth in this location? So it's very simple, right? BE is equal to 0.26 into cos delta is half, cos 60 is half. 2 will come this side, it will be 0.52 cos. Generally, how much is 1 cos? 10 power?
10
10
minus
power
4.
minus 4 Tesla.
Yes, 10 power minus 4 Tesla. So depending on how they are expecting the answer. If suppose they ask in MCQ, they can give you this option also. So please be careful. Okay. So all the problems are based on these things only. So whichever is not needed, I will strike it off.
Sir, can you show that answer 1 minute, sir?
Sure. Yes.
Thank you, sir.
Okay. Now see, these are the concepts, guys. So the other problems you can do, if you have any doubt, we can get it cleared in the next class. So I'll upload this assignment today. So try them before the next class. The ones which you need not do are the problems based on neutral points. If you see the word neutral point, you need not do it. Okay, that's not there in your syllabus. Okay. So any other doubt from this chapter? Any other doubt? So assuming there are no doubts, we'll start the last chapter of this first volume, that is electromagnetic waves. Write it down. So electromagnetic waves, and the chapter number is 8. So it is the 8th chapter. Okay. So what do you understand by these electromagnetic waves? So if you observe the first volume completely, as we discussed, the chapters are either related to electric field or related to magnetic field, right? That's what we had been seeing, right? Now, what does this electromagnetic wave actually mean? There are two terms associated. Both the terms are associated in the same word. So what exactly is this? Anybody?
Sir, waves caused due to electromagnetism.
What do you mean by electromagnetism? See, electromagnetism is a phenomenon, right? So I would have used the word electromagnet in the case of temporary magnets, right?
Yes, sir.
I guess able to relate. So what did I say there? Electromagnet refers to what in that context?
Sir, electrical waves and magnetic waves traveling mutually perpendicular to each other.
How did you know that they are mutually perpendicular to each other?
Last year.
I saw it somewhere last year.
Okay.
In chemistry, last year. Not wrong.
So in chemistry, you could have seen, because in Rutherford's experiment and all, they will say that when an electron is accelerated in a spiral orbit, it should lose energy and fall into the nucleus. That is one of the drawbacks of Rutherford's experiment. There you use the word electromagnetic waves. So this chapter is actually a very small chapter, and it is the building block for the next volume. Because if you see the next volume completely, it depends only on this topic, electromagnetic waves. So you need to understand what it is. Okay. So before I explain electromagnetic part, let me explain what a wave is. So what is a wave? So you people know what a wave is. It is a disturbance, right? It is a disturbance that is created. And what is the main objective of this disturbance? To transfer energy from one point to another. Okay. So disturbance created to transfer energy from one point to another. That is what is a wave generally. Okay. I hope you're able to understand. So waves are classified into different types. You would have learned this also. So waves are basically classified as mechanical and non-mechanical. I hope you have heard these terms, right? You need to have a clear understanding of this for the 10th chapter. So please listen to it carefully. At that point, I cannot explain again. So what is a mechanical wave? So what do you mean by mechanical wave? It is a wave which requires what?
A medium.
Medium.
Very good. Very good. Which requires a medium for propagation. So example of a mechanical wave is sound. Sound needs a medium to travel. Sound cannot travel in vacuum. Then what are non-mechanical waves? Obviously, they'll be the opposite, right? So waves which do not require medium. So waves which do not require medium are called as non-mechanical waves. I hope these 2 points are clear. So mechanical and non-mechanical is basically classified on the basis of whether a medium is required or not. Similarly, similarly, there are two more types of waves which are called as transverse and longitudinal. So as Dhruv told, this transverse and longitudinal is the one which is going to speak about the perpendicularity and the parallelism. Okay, so what do you mean by a transverse wave then? So what exactly does a wave contain? So what exactly does a wave contain? So you have particles. I told disturbance created. The question is disturbance created to whom? Disturbance created to the particles. Right? So disturbance created to the particles, and what is the main objective of the disturbance? To transfer energy from one point to another. So when you create a disturbance, let's say if the particles are vibrating and the wave is propagating mutually perpendicular to each other. So if the direction of vibration and the direction of propagation are mutually perpendicular to each other, then that type of a wave is called as transverse, because transverse means perpendicularity. According to physics, transverse means perpendicular. Similarly, if you look at longitudinal, longitudinal is related to length. So length is going to be one-dimensional. So what will happen in this case? The vibration of particles and the propagation of energy will be in the same direction. Okay, if that is happening, then that kind of a wave is called as longitudinal wave. Example of a longitudinal wave is again a sound wave, right? So can someone tell me how do the longitudinal waves travel? They travel in the form of what? They travel in the form of,
Compression and rarefaction.
that's right, compressions and rarefactions. Okay. Similarly, a transverse wave will travel in the form of crest and trough. TROUGH. So it will travel in the form of crest and trough. I hope you guys know this already, right? So these are all the basics of waves which you would have learned last year. Now the term waves is related to electromagnetic. Now let's try to break this word and analyze what exactly does electromagnetic mean. So what does it mean? Electro is a word derived from charge. Okay. And wherever charges are there, there is electric field. Then what about magnetic? So magnetic is related to magnetic field, magnetism, right? But what is the main reason for magnetism?
Moving charge. Charges.
Charge particles
Motion of
in,
charges.
yes, it's motion of charges, right? So electric field refers to the charges at rest, and magnetic field refers to charges in motion. Now I'm going to concentrate on one more important point. So how electromagnetic waves are going to get generated. So these are the basics, guys. Is there any doubt in this?
No, sir.
No, sir.
Example of transverse wave is light. Light is a form of electromagnetic wave. Okay. So you have electric field and magnetic field present in the same wave. Now we need to answer certain important question. So if electric field and magnetic field are there, how are they with respect to each other? Is electric field and magnetic field both in the same direction, or are they in the opposite direction, or are they perpendicular to each other, or they're in some random direction? We don't know anything, right? So we need to find out what exactly is going to happen. Since we have given the name electromagnetic, can I take the common point out of electric field and magnetic field? What is the common point in both? So for electric field, you need charge at rest. For magnetic field, you need charges in motion. So what is the common point? You definitely need the charge for sure. Okay. Depending on whether it is rest or whether it is motion, the type of field that is getting generated will be decided. Okay. That's what we are going to look into. Okay. Now the question is, when I say charge is the major source for electromagnetic waves, how should this charge move is an important question we need to answer. I hope you guys are able to understand. So, if you have to define electromagnetic wave, first I'll define, then I'll tell you the outline. So if you have to define an electromagnetic wave, write it down. It is a combined electric and magnetic field, which are, how are they? Which are mutually perpendicular to each other, and perpendicular to the direction of propagation. Is there any doubt? So it is a combined electric and magnetic field which are mutually perpendicular to each other, and perpendicular to whom? Perpendicular to the direction of propagation as well. So what should be the nature of an electromagnetic wave? It should be a transverse wave in nature. Okay. Is it clear till this guy? I just gave you the definition. I'll give you the explanation. Don't worry. Is the definition part clear? I hope you guys are able to visualize what exactly a transverse wave means.
Yes, sir.
Yes? Okay. Now, the important question that we need to answer is, what is the source of an electromagnetic wave? So that is going to be the heading. So what is the source of an electromagnetic wave? So electromagnetic waves are also called as EM waves. Okay. Now, I'm going to give you an explanation and then we will conclude. So the explanation for this is, so 2 points are clear to us. Electro is going to generate, the charges are going to generate electric field. So for electric field to exist, the charges have to be present, and majorly electric field can be observed when they are at rest. Right? So can I put the point like this? Write it down, okay? If a charge is at rest, then what will happen? If the charge is at rest, what will get generated?
Electric
Dash.
field.
Yes, you know the answer already. So electric field is associated with the charge. Electric field is associated with the charge, will also be static. So can I call it a static electric field? Okay. So in this case, what will happen? I'm asking you a question. Is there a possibility for electromagnetic wave to get generated in this scenario?
No,
No.
Why?
Sir.
because
There is
charge
no
is in motion for
Charge
motion
is
and
not
charge.
in motion.
Yes, exactly. So since the charge is not in motion, you cannot speak about magnetic field. So from this, I'm going to conclude there will be no generation of what? EM waves. As electric field is not varying with time. Okay. So one small addition. See, electromagnetic waves are combined time varying electric and magnetic fields. Please underline this word. Time varying means these electric field and magnetic field are going to be a function of time. I'll tell you how they are related later. So please add this point, time varying. I missed it. Combined time varying electric and magnetic fields which are mutually perpendicular to each other. Since we are using the word time varying, what is that you're able to understand? Since here we use the word static, there is no possibility of electric field to change with respect to time because it is going to have a constant value with respect to time. So I hope the first point is clear. Second. So what should be the second option? Now we saw what will happen when the charge is at rest. So what is the other thing you will do? You will try to put the charge in
Motion.
motion. So again, an important question comes. When I am trying to put a charge in motion, you can either put it in uniform motion or non-uniform motion. So what do you mean by uniform motion? From the basics of your kinematics, what do you mean by uniform motion?
Equal distances covered in equal amounts of time.
Yes, equal distances covered in equal intervals of time. Due to which, technically what will happen to the other two parameters? That is, now you spoke about distance. What will happen to the speed and acceleration?
Constant. Speed is constant, acceleration 0.
Very good. So the second option is, since we have tried what will happen with respect to charge at rest, now we will see what will happen when charge is moving with uniform velocity. So when the charge is moving with uniform velocity, then as you told, acceleration will be 0. Okay. So what will happen in this case? The change in electric field with respect to time is also a constant. Hence, there will be no EM wave generated. Okay, I'll explain the meaning right at all. So when the charge is moving with uniform velocity, then the acceleration is 0. This is a known point, right? Then what will happen to the change in electric field with respect to time? Then what will happen to the concept of change in electric field with respect to time? It will also be a constant. Hence, there will be no EM wave that is getting generated. Let me explain what the meaning is. Okay. So observe, you have a charge which is moving with a uniform speed, Q. There is a charge Q which is moving with uniform speed. So the electric field first point and the electric field at second point. Okay. Let's say the time taken to move from here to here is t, and here to here is also t. Okay, in the same time interval, what is happening? So, or I will take small distances dt. In time dt, let's say it is moving equal distances. That's what the definition says. Moving with uniform velocity means it is covering equal distances in equal intervals of time. So initially at t is equal to 0, when the particle was here, then there would have been one electric field existing here. Let me call it as E1. Let me say the electric field here is E2. Okay. And let's say the distance between these two is S, and here also it is S. Right? It is clear? I hope it is clear. Yes or no?
Yes, sir.
Okay, now listen to this. Okay. So, at t is equal to 0, when the particle is here, when it has come to this point, when you calculate the electric field at this point, it will have some amount of magnitude, which is, let me call it as E1. Now, after time dt, when the particle has come here, then what will happen to the electric field at this point? What will happen to the electric field at this point? It will still be E1 only. How did I say that? Because if I take this distance as q and this distance as s, then what is the electric field at the first point? E is equal to kq divided by s square. Accepted? So E1 is equal to kq divided by s square. Then when the particle comes here, from here till this point, what is happening to the distance?
It remains S.
It is remaining the same because the relative velocity, it remains the same. So what will happen is, After time dt, again E2 will also have the same value, kq divided by s square. So in the time interval, is there a change in electric field that is taking place? So is there a change in electric field that is taking place?
No.
No. So that is what the point is trying to say. So the change in electric field with respect to time is also a constant. What is required for an electromagnetic wave to get generated? You need a time varying electric and magnetic field. Means electric field and magnetic field should be a function of time for it to be called as an electromagnetic wave. Is that point clear?
Sir, but we
Yes
are
or no?
defining electric field with respect to a point, right?
Yes. But what is
Sir, but
happening in the time?
I have a
But
doubt,
what?
sir.
Yeah, tell me.
But
Tell me. I'm not able to hear. Your voice is
sir, can
breaking.
you repeat?
I'm not able to hear you.
Sir, but we are defining. Can you
Defining?
hear, sir?
Yeah. Tell me. Proceed.
So,
Yeah,
but we
proceed,
are
please.
defining electric field with respect to a point, sir.
Okay. But what is happening with respect to time? I've taken equal
Then how
intervals of
can
time.
this be true?
I'm talking about equal intervals of time. No, I'm talking after time dt. What will happen? So, see, it is all about relative concept only. Initially, I'll repeat it again. Listen. If I take this point as E1, if I take this distance as R, tell me what is the value of E1?
KQ divided by R square.
KQ by R square. Let's say it has traveled this distance in time dt only. I'm going to take small time intervals. Okay. Now, in the same time dt, next to dt, where would the particle be? So in time dt, this particle has come here. It's similar to the Doppler effect concept. It has come here. Okay. If I take this as q, then at this instant, what will be the value of electric field at this point? E2. Again, this distance is r. E2 will be equal to kq divided by r square. This is after how much time?
DT.
After dt seconds. So what is happening is when you try to calculate the difference of electric field between certain instances, what is happening? It is going to be a
It
constant value.
remains constant.
That is what the point
Okay,
means
sir.
actually. Okay. So that's why I told you with respect to time, wherever you see word restrict in physics, no, it is always a comparative study. That is how you need to approach. Okay. So third is what can you do to this one?
Sir, both are present.
Both are? There is no both.
Non-uniform.
We are talking only about charge. Initially, what did we do? We put the charge at rest. Secondly, we observe. We try to put the charge in motion with uniform velocity. Third, what will we try to do?
Non-uniform.
Okay. Wait, 1 minute. Yeah. So what will be the third case? The charge will be accelerated. That is a non-uniform motion, right? So what will happen when the charge is accelerated? Tell me. So when the charge is moved with uniform velocity, what happened to the electric field?
It remained constant.
So electric field was remaining constant with respect to time. It was not time varying. Now, if the charged particle is accelerated, can I conclude that electric field will change with respect to time? Am I right? Similarly, what will happen to the magnetic field? When a charged particle is in motion itself, see, actually, one more point to be mentioned here is when the charged particle is moving with uniform velocity, what will happen to the magnetic field, guys? So here what will happen is magnetic field is also independent of time. So that is why if you see a charged particle which is having a uniform motion cannot generate electromagnetic field. Then what will happen when the charge is accelerated? When the charge is accelerated, the electric field will change with respect to time. As a result of which the magnetic field will also change with respect to time. So when both are changing with respect to time, then what will happen? When both are changing with, so what is the source of an electromagnetic? This story and all, nobody will ask you to write. But what is the source of an electromagnetic wave?
The charge is
An
uniform.
accelerating.
Time varying.
It is an accelerating charged particle. So an accelerating charged particle is the one which is responsible for the electromagnetic wave. Is it clear?
Yes, sir.
So please make a note of it. So what will be the question is, what is the, so this is just a one mark question. What is the source of an electromagnetic wave? Answer is accelerating charged particle. That's it. Okay. Are you guys clear with this? So write down a note. Oscillating charged particle will have oscillating electric field which gives rise to an oscillating magnetic field. Okay, so here when I mean what I mean by oscillating is nothing but the particle which is put into acceleration. So last year you would have learned this, right? So what do you mean by oscillatory motion? So to and fro motion that is taking place about the mean position. So when the particle is moving from one point to from the mean position to the extreme point, what are all the changes the particle will undergo? One is its displacement is changing with respect to time. Then its displacement is changing with respect to time. Then what will happen? Its speed will change with respect to time, and acceleration will also be present. You would have learned this, A is equal to minus omega square x when the particle is in SHM, right? That's one of the types of oscillatory motion. So here also the same thing will happen. The particle will accelerate. So wherever you see the word oscillating charged particle, it is indirectly also meaning that the charged particle is accelerating as well. So if you see the word accelerated charged particle, the term electromagnetic waves should come to your mind. That is what I'm trying to say. Okay. So this will happen. Second is the above process will give rise to an electromagnetic wave. So the above process will give rise to an electromagnetic wave. The next one is frequency of EM wave is equal to the frequency of oscillating particle. Okay, so have this point in your mind. Frequency of an electromagnetic wave is equal to frequency of oscillating particle. So what do you mean by this? When the charged particle is oscillating, let's say with an angular velocity omega, then the particular electromagnetic wave that is getting generated will also have the same angular frequency omega. That is the meaning of it. So from this, one important point that we can conclude is frequency is the characteristic of the source. Frequency is the characteristic of the source. Okay, I hope you guys made a note of it. Is there any doubt?
So can you explain the third point, sir?
Which one? This one?
Above one, sir, the frequency of EM wave.
So EM wave means will have a frequency associated with it. If you want to calculate the frequency of that electromagnetic wave, it will exactly have the same value as that of the oscillating charged particle which is producing that electromagnetic wave. We told no oscillating charged particle will produce electromagnetic wave. Any particle that is oscillating will have a frequency associated with it. For example, in 1 second it is going like this and stopping here, means its frequency is 1 unit. Let's say in 1 second it is going like this, then its frequency will be 2 units, means it is able to complete 2 oscillations. It goes like this. So whatever is the frequency with which the oscillating particle is moving, it will be the same frequency. The electromagnetic wave will also have the same frequency. Okay.
Thank you, sir.
Yeah. And this is an important point. Please make a note of it. Frequency is the characteristic of source. Okay. Next is, if I ask you about the nature of EM wave, what type of a wave is it? Is it a transverse wave or a longitudinal wave?
Transfer.
It is a transverse wave. So in this transverse wave also, what is going to happen? The electric field and the magnetic field are mutually perpendicular to each other. Electric field is perpendicular to magnetic field and perpendicular to what? Propagation of wave. Okay, this is what is going to happen. So this is the nature of the electromagnetic wave. So these are all some important points. So points to be kept in your mind. First is source. What is the source? An accelerating charged particle, or in the advanced way you can say an oscillating charged particle. Both are the sources of electromagnetic waves. Second is when you speak about the frequency of an electromagnetic wave, the frequency of the electromagnetic wave will exactly be equal to what? Frequency of the particle.
Oscillating particle.
Yes, frequency of the oscillating particle, and have this characteristic of the source in your mind. Okay. Now see, I'm going to give you some mathematical equations. These equations also you would have seen last year. In case, or if I'll take it like this, if the EM wave is propagating along x direction, then electric and magnetic fields will be in which direction, guys? So what was the last point I told you? Electric field is perpendicular to magnetic field, and they both are mutually perpendicular to whom? The direction of propagation. Now it is here, given here. If the electromagnetic wave is propagating along x direction, then what should be the possible directions of electric and magnetic fields?
Like Y direction and Z direction.
It can be Y and Z. Anything can be in Y and anything can be in Z. Okay, it should be Y or Z. So we are taking only a particular case. So if I put it like this, if wave propagation is along x-axis, okay, I am assuming that the electric field is along y-axis. Then I am saying magnetic field is along z-axis. Since they are transverse in nature, what will happen is I'm going to write the equation of electric and magnetic fields. Okay. So if you recollect the concepts from last year, basics, you would have seen an equation like this: y is equal to a sine omega t. Did you guys see this? Y is equal to a sine omega t. Yes or no?
Yes, sir.
So this equation represents what? Y is equal to a sine omega t represents the equation of a particle in which type of motion?
Oscillator.
Particle in SH. So when you talk about a particle in SHM, we write it as y is equal to a sine omega t. So there is another equation, if you see, a sine of kx minus omega t. Did you guys see this? Y is equal to a sine of kx minus omega t. Yes or no? You have never seen this equation at all. Huh? This is the equation of a traveling wave. So if there is a wave which is traveling or propagating, then the equation of the wave is given as a sine kx minus omega t, where a represents what?
Amplitude.
Amplitude.
K represents what?
Propagation constant.
It's called propagation constant. What is the other name for it? Propagation constant is right, but there is another name for it.
Wave number.
It is called angular wave number. Okay, so you're almost there. Wave number means the reciprocal of wavelength. Angular wave number means wave number multiplied with 2 pi. So k is equal to 2 pi by lambda, which is also called as angular wave number. What is the other name for it? Somebody told. It's a propagation constant. It's a propagation constant. Similarly, what does omega stand for?
Angular.
It is called angular frequency. So you guys asked me, what exactly that frequency you're trying to talk about, this omega. So angular frequency is this much. Then angular frequency, how is it related to frequency? It is 2 pi into f. This we have discussed many times, right? So this is frequency. Omega is angular frequency. I hope you guys are able to understand this point. So are you guys clear with when to use which equation? You will use this equation only when there is an oscillatory motion that is existing. Whereas you will use the bigger equation a sine kx minus omega t when there is an oscillation and propagation taking place. So in this case, tell me, is a particle only oscillating or is it propagating also?
Propagating.
It is propagating also. So what should we use? We should use the second equation. Since we have told that the electric field is along y-axis, then observe the way I'm going to write the equation. Ey is equal to E naught sine of kx minus omega t, where x represents the direction in which the wave is propagating. So Ey is equal to E naught sine kx minus omega t. Okay. Similarly, what will be the value of By? B naught sine of kx minus omega t. There is a mistake in this equation, correct it?
BZ.
Z.
Yes. It should be Bz. That's right. Okay. But if you observe one thing in common, it is kx, here also kx, minus omega t, minus omega t. Generally, the minus sign indicates, negative sign indicates wave is traveling in positive x direction. So when the wave is traveling in the positive x direction, we use a minus sign. Similarly, if you use plus, it is a reflected wave. Is this point clear?
Yes.
Okay, make a note of this. You might get problems based on these equations also. So what they will do is they'll just give you some expressions. Suppose they give you Ey is equal to, let me create something. So E naught sine ky minus omega t. Okay. They're saying Ey is equal to E naught sine ky minus omega t. First, tell me what is the mistake in this?
Kx.
Kx.
It should either be kx or kz, because electric field and the propagation cannot be in the same direction. It should be perpendicular. If I take kx for example, okay, then, or I will take like this, kz. Then indirectly they'll ask you to write the equation for magnetic field. So how you write the magnetic field? Format is the same. B is equal to B naught sine of whatever is angle, just copy it, kz minus omega t. What is it you need to do?
BX.
That's it. So this will be a 1 mark question. Okay, I've seen questions like this. So you might get something of this sort, or they will give you Ey is equal to, let's say 2.25 into 10 power 3 sine 5x minus 2 pi into t. Then they'll ask you to calculate the frequency. Then what will you do? Compare with the original equation. Here you will have omega. So omega is equal to 2 pi, but omega is already 2 pi into f. So 2 pi into f is equal to 2 pi. This and this will get cancelled. F will be 1 hertz. So something like that. I've just created some random problem, okay? But I hope you guys are able to understand what kind of questions can come. Yes? Yes or no?
Yes, sir.
Okay. Next. The last concept for the day is speed of an electromagnetic wave. See, after this, you have 3 more subtopics for this chapter to get over, but they are simple only, that I'll finish in the next class. So till then, you can revise till this point. Now, I'll complete speed of electromagnetic wave alone. Okay. Now, tell me, what is the value of mu naught by 4 pi? We have used
10 to the power minus 7.
10 power minus
So 10 power minus 7. Okay. Similarly, what is 1 divided by 4 pi epsilon naught?
9 into
9
10.
into 9 to the power 9.
9 into 10 power 9. Now the question is, if I divide both, mu naught divided by 4 pi divided by 1 divided by 4 pi epsilon naught is equal to, what will happen? 10 power minus 7 divided by 9 into 10 power 9. So 4 pi and 4 pi are gone, which implies mu naught into epsilon naught is equal to what? 1 divided by 9 into 10 power 16. Can I write it like this? Because 10 power minus 7 comes down, it will become 10 power 16. So what is 1 divided by mu naught into epsilon naught? It is 9 into 10 power 16. Right? If I take square root on both the sides, 1 divided by square root of mu naught into epsilon naught, it will be 3 into 10 power 8. What is this value?
Speed of
Speed of light.
Speed of light.
So this is what is the speed of light in vacuum, because mu naught and epsilon naught is what we are going to speak. So are you guys able to understand? So going forward, we will use C is equal to 1 divided by root of mu naught into epsilon naught also. So same thing can be derived when you write C is equal to E divided by B also. It is something similar to the velocity selector concept that we discussed. V is equal to E divided by B. So what I mean by saying E divided by B is you have these equations, right? E divided by B. We can get it from this one also, but this point is enough.
Sir,
Yeah, tell me.
the Tarun is waiting, it seems, sir.
Okay. So you can come now.
Okay, sir.
Are you guys clear? Any doubt?
Yes, sir.
Right? So as I told you, there are only 1 minute. Energy of an electromagnetic wave and properties of electromagnetic wave, EM waves, exert pressure. That's it. There are only 3 subtopics that are pending for this chapter. After this, we can start ray optics. Okay. So with the hope that there are no doubts, we can wind up this session. If there are any doubts, let me know.
No, sir.
Okay.
Sir,
Yeah.
sir, can you send the notes for the previous lesson?
Which lesson? Yeah, this one, huh?
Magnetic.
Okay. Yeah.
Okay, sir. Thank you, sir.
Yeah. So we can wind up the session. We can leave. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank
Thank
you,
you,
sir.
sir.
Sir. Thank you, sir.
Yeah.